Brent, today, also through your great lecture, you showed us, first of all, the evidence that polymer science and polymer chemistry has been extremely relevant in terms of technology, but also research and fundamental research in academia. And this has, especially in the United States. So nowadays, we have big challenges, especially in this historical period. Why governments and institutions should continue supporting basic, fundamental, and applied research in polymer chemistry and polymer science?
Yeah, I think that the relevance of polymers to our lives is continually increasing. For many years, we've thought of them as being commodity materials, things that are used for packaging. Relatively, we're thinking of polymers as being inexpensive and maybe just routine use type things. But suddenly, I think we've realized, or maybe not suddenly, but over the years, we've begun to appreciate the fact that we can make polymers that can serve much higher purposes. We can use them for drug delivery. We can use them for in vivo imaging. We can use polymers to help us deliver antibiotics to crops to increase food production. We can make them into electronics or solar cells. And I think we're taking the learnings that we developed over the years and how to make polymers on a massive scale and now beginning to apply them to more specialty type materials that really begin to address some of the most critical issues of our time.
Absolutely. So what's the next challenge for a polymer chemist as you are?
Yeah, it's a great question. I think one could make the argument that these materials we talked about that have, without a doubt, revolutionized the world. I mean, including, for example, isotactic polypropylene, developed here in Italy. I would argue one of the most important man-made materials ever created. Having said that, a lot of these commodity plastics have now become recognized that they're problematic. They're persistent, and I think one could really argue that polymer chemists have really done their jobs too well. We've made materials that are too robust, and they last too long, and they cost too little, which ironically is exactly what we were trying to do. But it turns out that that's a problem, especially the fact that they last too long. So now it's a matter of what do we do with these plastics now that they're around? How do we remove them from the environment? And I think it probably is the responsibility of polymer scientists to help address the problems that arguably they helped to create. So if we think about the future, I think one of the things to consider is really how do we address plastics that are persistent in the environment already? Can we think of ways of remediating them and doing so in a responsible manner?
Mm-hmm. And one last question. Why you would suggest to a chemistry student, undergrad, to consider polymer chemistry and polymer science as a very big opportunity for the continuation in their career, in his career or her career, both in academia and in industry?
Yeah, obviously I'm very biased in this respect, but polymers excite me and excite you. And I think that the younger generation, I think they already see this. We have a really great opportunity to work on science that actually matters, that actually affects people's lives. We're not working in some area that's incredibly esoteric that a limited number of people care about. The types of materials that we're interested in and that we're helping to work on are materials that people encounter on a daily basis. And they're materials that can revolutionize life and society as well, especially if we think about drug delivery or agriculture, et cetera. Yeah. I think we have a way of both doing something fundamental, but also having chemistry that's very obviously applicable to the real world. And I think that's really an interesting take on things for the younger generation, especially because they're going to be the ones that can really benefit from this the most. I would argue that if we think about looking back to your second question and the issue of sustainability, as we're designing new polymers for the future, it's probably good for us to consider their end-of-life fate when we're designing them at the very beginning. Like right now, we're trying to fix a pre-existing problem, but what if we design polymers knowing that down the line, they'll be more readily recyclable, more readily recoverable, more readily degradable? And the next generation of young scientists, I think, are really equipped with the tools to address those types of problems.
Absolutely. Thank you very much.
Absolutely.